Because most elements we find in nature are made up of a mixture of isotopes, we need a way to come up with an average atomic weight that represents a mixture of these isotopes and a large amount of the given element. So we use what's called the average atomic weight for an element, and that's just equal to the percent abundance times the weight of the actual isotope. And we do this for each of the isotopes in the mixture. So here we're looking at 2 isotopes. However, we could possibly have 3 or 4. We would just add more onto this actual equation. So when we were looking at the carbon-12 atom, we realized that there was a mixture of isotopes in there. About 98.9% of carbon is the carbon-12 isotope, and we've already decided that the atomic weight for that is going to be exactly 12 AMU. However, there is about 1.1% of a carbon isotope called carbon-13, and that, of course, because it has an extra neutron, is going to have a different atomic weight. The idea is now when I have, many carbon atoms, what is going to be the average atomic weight for them? So we use this relative abundance calculation. So one of the things you need to remember, and this is a very, very common mistake, when we write 98.892%, this is how we describe it, but this is not a mathematical percent. I can't use this number in a calculation. I need to divide these numbers by 100 when I start doing mathematical calculations with them. And this is a very, very common mistake, and we're going to see this a few different times in general chemistry. So if I take this number and divide it, that tells me the percent of the carbon atoms that are carbon-12, and we know what the atomic mass of carbon-12 is. So this will give us the relative atomic mass for carbon-12, and then we do the same thing for carbon-13. We take this number, divide by 100, multiply it by its atomic weight, and when we add these two numbers together, we get the 12.011 atomic mass units that are reported on the periodic table. So here's a variation of the question, and one of the other things professors can ask on exams is to come up with the percent abundance or the atomic mass of one of the isotopes. I really wanted to show you this question because it has one of my more favorite kind of tricky questions that I can ask on an exam, and one of the things they do is they don't give you the average atomic mass in the actual problem. So here, say I didn't give you the average atomic mass of bromine, it looks like they didn't give you a piece of the information. But if they give you the periodic table, they actually have given it to you, and that's something that I like to test, is to see if people understand that the average atomic mass is actually the number that's reported on the periodic table. So if they give you the periodic table, they give you this number, and it's up to you to come and look at it. So let's just run through the rest of this question. You can find that there are kind of shortcuts and ways to check your answer. Bromine actually has 2 isotopes, and there's bromine 79, which has an abundance of 50.5, and then there is bromine 81, which has an atomic weight of 80.9 and an abundance of what we're looking for. So we say, what's the abundance of bromine 81? So the average atomic weight we get from the periodic table that goes there. And then what I like to do is look for the variables. So here we're looking for the percent abundance of one of the isotopes. So I give you the percent abundance and the weight of one of the isotopes, bromine 79. I give you the atomic mass of bromine 81, and we want to find the percent. So we put that as an X value, and we go ahead and solve for it. So remember, you get the number 0.495. So if you want to put it in a percent value, you write it out as 49.5. And then one of the ideas you need to keep in the back of your head if you're doing these type of calculations, that theoretically when you add all the percent abundances together, it should equal pretty close to 100%. So when I told you that bromine 79 had an abundance of 50.5%, and I also told you that there was only 2 isotopes, then it became pretty clear that bromine 81 should be roughly 49.5%.